Hey everyone, and welcome. So you've just come out of your Class 10 physics exam. First things first, just take a deep breath. We're about to do a quick, stress-free rundown of some of the key questions you probably saw. Let's clear things up. I totally get it. That feeling you get right after an exam, wondering, did I get that right? It can be pretty intense, right? You're replaying all those questions in your head. Well, that's exactly why we're here.
So, here's what we're going to do. We're going to break down 10 key concepts that showed up, based on questions students remembered from the paper. Now, the goal here isn't to grade you or anything like that. It's just to walk through the main ideas so you can feel good about what you know. Okay? Let's dive in.
First up, let's tackle the world of light, mirrors, and lenses. Optics questions are always a huge part of the paper. So let's see what they threw at you this time.
A classic, a concave mirror question. They're asking about that one single special case where the image isn't real, it's virtual. Do you remember the rule for this one?
So the thing you have to remember about concave mirrors is that for most positions, they create a real image. The big exception, the one trick they have up their sleeve, is when you place the object inside the focal length. That's the magic zone.
And there you have it. That's the answer. The object has to be right there, between the pole, which is just the center of the mirror's surface, and the principal focus. You put it there, and you get a virtual, upright, and bigger image. It's exactly how a makeup or a shaving mirror works, right? You have to get super close to the mirror to see that magnified reflection.
All right, let's switch gears from mirrors to lenses. This question is all about magnification, but this time for a concave lens. And honestly, this one's all about remembering one simple rule.
Here's the deal with concave lenses. They're super predictable. They always, and I mean always, make an image that is virtual, upright, and smaller than the object. So what does that tell us? Well, upright means the magnification has to be positive, and smaller means the magnification has to be less than 1.
So if you saw a few different options on the exam, you were looking for the number that fit those two rules. Something like positive 0.75 is a perfect fit. It's positive and it's less than 1. Simple as that.
Okay, our last optics question is a real fundamental one. It's just asking about the formula that connects two of the most important measurements for any curved mirror or lens.
And boom, there it is. One of the simplest but most important formulas in all of optics, R equals 2F. The radius of curvature is just double the focal length. It's a nice, clean, direct relationship. Now let's move on.
Okay, let's swap our lenses for lab coats because we're heading into the chemistry section. Time to look at some of those puzzles with reactions, naming, and of course, pH.
All right, here we've got a stoichiometry problem. The key things to notice are the 46 grams of sodium and that really important little detail, the reaction is happening at STP, standard temperature and pressure.
So whenever you see STP, your brain should immediately flash on one magic number, 22.4 liters. That's the volume that 1 mole of any gas takes up under these standard conditions. Now the trick here is figuring out how much hydrogen we're making. Well, 46 grams of sodium is exactly 2 moles. And if you look at the balanced reaction, you'll see that 2 moles of sodium produce 1 mole of hydrogen gas.
And there you go. Since we're making exactly 1 mole of hydrogen gas, the volume it's going to occupy at STP is, you guessed it, 22.4 liters. That's the answer.
Next up, a classic from organic chemistry, naming a compound using the IUPAC system. This is all about just following a clear set of rules, step by step.
Okay, so what do we do first? We find the longest continuous chain of carbons. In this molecule, that's 3 carbons long, which gives us the base name propane. Easy enough. Then we look for any branches. And yep, we've got one, a little single carbon group, which we call a methyl group, and it's attached to the second carbon in that chain.
Now you just snap those pieces together. We have a methyl group on the number 2 carbon of a propane chain, so the name is 2-methylpropane. See? It's like building with Legos. Totally systematic.
Let's jump back to general chemistry with a question about the pH scale. You were asked to spot the pair of values that would represent a strong acid and a strong base.
And this is super straightforward, right? Think of the pH scale like a ruler from 0 to 14. The really, really strong acids, they live way down at the bottom, with pH values close to 0 or 1. And the really strong bases, they're at the complete opposite end, way up top, with pH values close to 14.
Okay, our last chemistry question is about drawing molecules.
How do you actually represent fluorine gas, F2, with its electrons?
And it's really as simple as this. Each fluorine atom is just one electron short of having a full, stable outer shell. So, what do? Two fluorine atoms get together, each one shares one of its electrons with the other, and bam! They form a nice, stable, single covalent bond between them. Everybody's happy.
All right, for our last set of questions, let's plug into the world of electricity and magnetism. We're going to look at how charges move, what instrument readings mean, and the whole idea of induced current.
This question is really asking if you understand what's happening inside a solution that can conduct electricity, an electrolyte. More specifically, where are the positive charges headed?
Just remember the most basic rule in all of this. Opposites attract. So, the positive charges, which we call cations, are naturally going to be pulled toward the electrode that's negatively charged. And the name we give that negative electrode is the cathode. So positive charges move to the cathode. It's the whole principle behind how electroplating works.
Okay, this is a practical one about using a common piece of lab gear. If you hook up your multimeter and all it shows is a 1 way over on the left side of the screen, what on earth is it trying to tell you?
Yeah, this isn't a measurement of 1. It's basically the multimeter's way of screaming for help. It means that the thing you're trying to measure is just too big for the setting you've chosen on the dial. It's telling you that the measurement is out of range or you've created an overload.
And for our very last question, we've got a big conceptual one about electromagnetic induction. What's the fundamental thing, the root cause, that actually gets an induced current going in the first place?
The bottom line is, you can't have a current without some kind of push. And in the world of induction, that push is called the induced electromotive force, or EMF. A changing magnetic field creates that EMF, and the EMF is what actually sets the induced current into motion. It's the core principle that makes everything from giant power plant generators to your wireless phone charger work.
So, we've covered a lot of ground from light waves to flowing charges. Let's just do a super quick recap of the core scientific ideas that were really at the heart of all these questions.
So, here are the big takeaways. In optics, we saw that a concave mirror makes a virtual image only when the object is super close, between P and F. And for concave lenses, the magnification is always positive and less than 1. For chemistry, that magic number at STP is 22.4 liters, and when you're naming compounds, you always find the longest chain first. For acids and bases, it's all about the ends of the scale. Strong acids are near 0, strong bases are near 14. And finally, you can't have an induced current without an induced EMF to kick it off.
At the end of the day, an exam like this isn't just about memorizing a bunch of facts. It's really a test of whether you can apply these fundamental rules. It's about understanding the why behind it all. Hopefully this little walkthrough has cleared some things up and made you feel a bit more confident. So take a second and think, which one of these ideas feels the most solid to you right now? Thanks for going through this with me.